In the last video, we went over the first two redirections, standard input and the standard output redirections. Let's go ahead and talk about error redirection. The three data streams attached to any Linux command actually have numbers associated with them. You see them between parentheses. stdr is stream number 2, and we can use these numbers to identify the streams. If we place a number before the greater than operator, then it will redirect to that stream. If we don't use the number like we have been doing so far, then it defaults to stream 1, which is standard output. Let's see some examples. I'm running a command which will return an error. tail -n3/etc shadow. An unprivileged user cannot see that file. To redirect the error message to a file, I'll use to, which is the ID of standard error, and the greater than. You are not allowed to put any spaces between to and greater than. And the file, error.txt. The file was created, and this is its contents. Notice how the error was redirected to the file that was also created because it didn't exist. In fact, the same rules we saw at output redirection apply to error redirection as well. If you want to append to the file instead of overwriting it, use to and the double greater than sign. I'm executing the same command again, this time using to and double greater than operator. The error message was appended to the file. It's also possible to redirect both the standard output and error of the same command if the command produces both normal output and errors. Let's try an example. tail-n2, etc password, etc shadow, greater than output.txt, 2 and greater than errors.txt. The tail command produced both normal output and an error message. The output was redirected to output.txt and the error message to errors.txt. Sorry, I have misspelled the file name, but you got the point. In the next example, I'll show you how to redirect both stdout and stdr to the same file. What I'll do is redirect stdout to a file and stdr to stdout. I'll run the last command. So I'm redirecting stdout to output underline errors.txt, and I'm redirecting stdr to stdout, but I'm writing an ampersand before the number that identifies stdout. So ~1. This is the file that was created, and this is its contents. We see there both the stdout and the stdr of the command. Note that the file contains both the output and the errors. One remark here, I've redirected to a stream by placing an ampersand in front of the stream number. Take a look here. Otherwise, it would have been redirected to a file called 1. You can also combine command redirection with pipes. Let's take a look at an example. I have config. Let's filter the line that contains the MAC address using piping. This line. So I have config pipe grep ether. And I've got the line. And I'll save the output to a file. The output of the command was saved to a file instead of being printed at the terminal. By the way, if you just want to get the MAC address without extra strings, you could run ifconfig, grep, and cut. I am piping to cut -d and a space in double quotes and the -f6. Sorry, x10. And I'm redirecting the output to mac.txt. And I've got the MAC address. By the way, cut cuts out fields of the output using a delimiter, which is a space in this case. There are 9 spaces, so 9 fields up to the MAC address, and I wanted the next field, which is field number 10. At the end of this video, I'll show you something useful. What can we do if at the same time we want to store and view the output of any command? If I use the redirection operators, the output will be redirected to a file without being displayed at the terminal as well. Here the T command comes into play. Its name comes from the T-splitter used in plumbing. It basically breaks the output of a program so that it can be both displayed at the terminal and saved to a file. Let's take a look at an example. ifconfig pipe grep ether is displaying the output only on the screen, and ifconfig pipe grep ether greater than mac.txt is saving the output to a file. The following command, with the help of the T command, writes the output both to the screen and to the file. So, instead of redirecting to the file, I'm adding a new pipe and then t mac.txt. We see that the output was both displayed on the screen and saved to the file. By default, the T command overwrites the file. You can instruct T to append to the file using the option -a, as in the next example. Who pipe t -a mac.txt. It has both displayed the output on the screen and appended it to the file. You can also write the output to multiple files. For example, you name -r, it's displaying the kernel's version, and I'm piping it to t-a mac.txt and kernel.txt. uname -r is displaying the running kernel version. Great, that's all about redirections, and now, having explored redirections, we have covered all the steps of how Bash processes the command line. After this final step, Bash will just execute the command. We are at the end of the section and have reached an important milestone. You now know in depth how Bash interprets the command line, and you are really on top. Now, to summarize everything, I've added one more video where we'll recap what we've learned so far with a real example. See you back in a moment.